Welcome to another episode of Math Made Simple. I'm Miss Munah and I'm a math specialist here at the Pi Lab. In this video, I'll be analysing some common examination questions. I've put the question in a handout and you may download a copy for free by clicking on the description box below. So let's get started. We're going to solve this question using the prime factorization method. So let's read the question together. There are 140 pieces of 3cm cubes. Now, in the very first sentence, there are actually two important pieces of information. The first being 140 pieces of cubes. The second being 3cm cubes. What does 3cm cubes mean? It means that when you're building the cube, each side of the cube is 3cm. So in this sense, the question is a little bit trickier because we are no longer dealing with 1 centimeter cubes. We're dealing with 3cm cubes. Now, what about the 140 pieces? What does this mean? Because we're going to make up a cuboid, like shown in the picture over here, 140 pieces would actually make up the volume. So this 140 actually make up the volume of the cuboid, which brings us to the next step. We are actually going to break up 140 using the prime factorization method. Now, if you have done this correctly, you should get 2 squared times 5 times 7. But I always like to break it up into individual factors so that I can see which numbers make up 140. And that would be 2 times 2 times 5 times 7. Now, what's the next clue? The next clue is here. The perimeter of the base is 72. Now, where's the base? Some of you may be asking, right, where's the base? So the base is actually at the top over here. And the perimeter is these 2 length and 2 breadth. So I'm just going to label this as 72 cm. Now, this 72 cm refers to the perimeter. But does it mean that there are 72 cubes along the 2 length and the 2 breadth? What do you think? Yes, the answer is no, because we are dealing with 3cm cubes. So definitely there shouldn't be 72 cubes. In fact, there are only 72 divided by 3, which is 24 cubes along the perimeter. Now, since there are 24 cubes along the perimeter, we can narrow this down to 24 divided by 2. Which is 12 cubes along the breadth and the length. So now, how do we use this 12, the number 12, to help us find the 2 possible heights of the cuboid? Okay, where is the height? Since we know that the length and the breadth are over here, the height would actually be this measurement over here, isn't it? This will be the height, H for height. Okay, so for labeling purposes, we're going to label, I'm going to write down NL to be my number of cubes along the length, and NB to be my number of cubes along the breadth. Okay, why do I need this NL and NB? Because I cannot say that my length plus breadth is equals to 12. That's wrong, right? Okay, because 12 is actually the number of cubes, not the actual perimeter. So I cannot do this. Now, this means that my NL plus NB actually has a total of 12 cubes altogether. Okay, how is this useful to us? Because if we can guess the number of cubes along the length and the breadth, which is actually the possible sums of 12, I can actually figure out my 2 possible heights, isn't it? So my very next step would be to start guessing. So how do I guess? Okay, just set up a simple table, like so. So in the first column, I'm going to write down NL, or the number of cubes along the length. In the second column, NB, the number of cubes along the breadth. And finally, in the third column, I'm just going to write down check, which means that I'm going to use this column to either accept or to reject possible combinations of the number of cubes along the length and the number of cubes along the breadth. So we have 12. Now, how do you get a sum of 12? Can I begin with a 0 and a 12? Okay, definitely not, because I cannot have 0 cubes making up the length or the breadth. So the minimum or the smallest number would be 1. Now, if one side is 1, to get 12, I need the other side to have 11 cubes. So I'm going to start listing all the possible combinations. So this is combination number 1. Number 2 would be 2 and 10. The third combination would be 3 and 9. Fourth combination would be 4 and 8. Fifth combination would be 5 and 7. And the last combination would be 6 and 6. So there are actually 6 total possible combinations. But because the question gave us a clue, there are only 2 possible heights, which means that out of a total of 6, I need to eliminate 4 of them. So which ones do I eliminate? This is where we're going to use the prime factorization of 140 to help us. So if we look at the first combination number 1, do you think it's possible to have 11 cubes along the breadth? Okay, remember, your 140 actually make up the volume. So 140 here, or your 2 times 2 times 5 times 7, is actually your length times breadth times height. So if I'm going to get 11 cubes along the breadth, I have to check my factors of 140. Do you think it's possible to get 11 cubes? The answer is no. Now, let's take a look at combination number 3. Is it possible to get 3 cubes along the length? Again, if you look at the factors of 140, the answer is no, because I cannot find 3 anywhere in the factors of 140. And if you look at combination number 6, how do I get 6? 6 is actually 2 times 3. And because I cannot have a 3 in my factors of 140, this is also not a possible answer, which leaves us with 3 combinations, isn't it? Number 2, number 4, and number 5. But I only want 2 possible heights, so I have to eliminate one of them. Now, if you look at combination number 4, you realize that, I can make up 4, right? From my factors of 140, because they are 2 times 2, which gives me 4. But recall that 8 is actually 2 times 2 times 2. I need 3 sets of 2s to make up 8, which is impossible. Do you see? I'm only left with 5 and 7. I no longer have an extra 2. So combination number 4 is out of the question. And that's good news, because now we know that combinations number 2 and 5 will give us the answer. So let's just check. Is it possible for us to get a breadth of 10? Or rather, the number of cubes along the breadth, can it be 10? Yes, because I have 2 and 5, which are factors of 140. And 2 is also a factor of 140, so this is possible. What about 5 and 7 for combination number 5? Okay, 5 and 7 are also factors of 140, so this is another possible combination. And finally, we can actually answer the question. So how do we answer the question? Recall that we are dealing with 3 cm cubes. So first step, we're going to find the 2 possible heights. So I'm just going to label the first height as H1, which means that if I have 140 cubes, okay, I don't know whether you still remember this formula, but in order to find the height, this would be the volume divided by the base area. So if I take 140 divided by base area, which is 2 and 10, I actually get 7. Okay, but recall that 7 is just 7 cubes. It's not the actual height, because we are not dealing with 1 cm cubes, we are dealing with 3 cm cubes. So it will be 7 times 3, which is 21 cm. So the first possible answer is 21. The second possible answer would be my volume, again 140 divided by combination number 5, which is the base area will be 5 times 7, and this would give me 4 cubes. But again, each cube is 3 cm in length, so I need to times 3, so the answer would be 12 cm. So our final answer would be a height of 21 cm and a height of 12 cm. And that's it. Thank you for watching. I hope you have enjoyed this video. If you found this video useful, give us a thumbs up. If you would like to check out more videos by us, please click on the links on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I'll see you guys again next time. Bye!